December 23, 1872, Tacony, Pennsylvania. The metallurgy report from Sheffield's finest steel experts would never fully capture what they witnessed in Henry Disston's crucible furnaces that winter morning. American steel workers, forging saw blades using methods that defied everything European tradition said was necessary for quality steel. Through the smoke and heat of the Pennsylvania factory floor, molten crucible steel poured at 1600 degrees with precision that seemed impossible to English observers. No centuries-old guild secrets, no generational apprenticeships, no Sheffield clay. Yet they produced blades with sharpness that English saws could not match. In Sheffield workshops, master craftsmen's blades dulled after 60 sharpenings. Each saw required constant maintenance, frequent filing, careful storage, eventual replacement. Most carried the reputation of the world's finest steel. The Americans were operating with metallurgy philosophy the English had never imagined possible. Pennsylvania coke, modified crucible design, industrial scale precision, quality standards that produce blades lasting 400 sharpenings instead of 60. 3,000 miles from English workshops, the most decisive steel-making revolution in industrial history was revealing itself, not in superior tradition, not in ancient methods, but in the systematic innovation that connected American materials in ways Sheffield's 200-year monopoly never imagined possible. The December wind cut through the streets of Philadelphia like a blade through soft pine, carrying with it the acrid smell of coal smoke and the metallic tang of industrial ambition. Henry Disston stood before the towering brick smokestacks of his Tacony works, watching steam rise from the crucible furnaces that had consumed his fortune and increasingly his confidence. At 53, the English immigrant had already achieved what most men only dreamed of, transforming a small saw-making shop into America's largest blade manufacturer. But on this bitter morning, watching his workers struggle with another batch of cracked crucibles, he wondered if his greatest gamble would also be his last. The numbers haunted him like a creditor's knock at midnight. English saw steel arrived in Philadelphia at $200 per ton, shipped across the Atlantic with Sheffield's centuries-old reputation intact. His experimental crucible furnaces consumed $300 worth of Pennsylvania coke and imported clay crucibles to produce the same amount of steel. Every batch represented a calculated loss that his accountants documented with increasing alarm. The mathematics of industrial competition were brutally simple: produce better steel at lower cost, or watch Sheffield's established houses reclaim the American market they had dominated since colonial times. Inside the furnace hall, 34-pound batches of blister steel melted in clay pots heated to 1600 degrees Celsius. The process itself seemed almost medieval in its simplicity: raw steel broken into chunks, packed into crucibles with precise amounts of charcoal, then heated until the metal achieved the molecular uniformity that distinguished crucible steel from common iron. But simplicity masked complexity that had taken Sheffield's masters 2 centuries to perfect. The clay crucibles, imported at enormous expense from Stourbridge, cracked under thermal stress with maddening frequency. American workers, lacking the generational knowledge passed down in English steel-making families, produced batches with carbon content ranging from 0.8% to 1 4/10%. Some blades emerging too soft to hold an edge, others brittle as window glass. The stakes extended far beyond Disston's personal fortune. After the devastating fire that had destroyed half his original factory, he had committed everything to this 300-acre complex in Tacony, a company town built around one impossible promise: American Crucible Steel would outperform Sheffield's finest. His workers, 800 strong by Christmas, depended on wages that flowed from furnaces that increasingly resembled expensive failures. The row houses he had built for their families, the company store that extended credit during lean weeks, the school that educated their children, all of it balanced on crucibles that shattered with soul-crushing regularity. Sheffield's experts had visited in autumn, their confidence radiating like heat from a well-banked forge. They examined his furnaces with the casual dismissal of men whose grandfathers had supplied steel for Wellington's army against Napoleon. Crucible steel making, they explained with patronizing patience, required more than American enthusiasm and Pennsylvania coal. The process demanded knowledge accumulated over generations, the precise ratios of clay and ground crucible fragments that created vessels capable of withstanding thermal shock, the firing rhythms that ensured even heating, the intuitive understanding of when molten steel achieved perfect consistency. These secrets, locked in Sheffield guilds and transmitted only through decades of apprenticeship, could not be replicated by colonial upstarts with more ambition than expertise. Yet Disston had made claims that even he sometimes questioned in the dark hours before dawn. His American Crucible Steel would produce saw blades capable of 400 sharpenings while maintaining cutting efficiency. Sheffield's finest managed 60. The metallurgical basis for such superiority remained theoretical: superior Pennsylvania coke that burned cleaner and hotter than English coal, American iron ore with lower phosphorus content, manufacturing methods freed from tradition's constraints. But theory meant nothing when crucibles exploded and batches cooled into expensive scrap metal. The crisis deepened when his largest customer, a lumber operation in Michigan, returned 200 saws marked defective. The failure rate had reached 23%, nearly 1 blade in 4 proving unusable after initial field testing. Carpenters who had trusted the Disston name found their saws dulling after a dozen cuts, bending under pressure that quality steel should easily withstand. Word spread through lumber camps and furniture workshops with the speed of bad news. The carefully built reputation that had taken years to establish crumbled with each returned shipment. Philadelphia newspapers sensed blood in industrial waters. Disston's folly became a favorite headline, accompanied by editorials questioning whether American manufacturing could ever match European standards. English competitors, reading these reports with satisfaction, responded by slashing prices 40% below cost, a temporary sacrifice designed to eliminate American competition before it could perfect its processes. The strategy was sound and ruthless. Drive Disston into bankruptcy during his vulnerable period, then restore prices once Sheffield's monopoly was secure. The weight of failure pressed down on the Tacony works like December snow on factory roofs. Workers who had relocated families for steady employment now whispered about job searches in Pittsburgh's steel mills or Chicago's rail yards. The company town that had represented American industrial ambition began to feel more like a monument to overconfidence. Master craftsmen imported from England at enormous expense shook their heads over shattered crucibles and inconsistent steel, their expertise frustrated by conditions that differed subtly but crucially from Sheffield's workshops. Standing in the furnace hall, watching another batch of crucibles heat toward their breaking point, Henry Disston faced the possibility that his vision of American steel superiority might remain forever theoretical. The immigrant who had arrived in Philadelphia with nothing but skill and determination now commanded an industrial empire balanced on the edge of catastrophic failure. 800 jobs, 300 acres, and the future of American steelmaking hung in the balance, suspended like molten metal in crucibles that might shatter at any moment. The January snow that blanketed Tacony carried more than winter's chill. It brought desperate inspiration wrapped in secrecy and risk. Henry Disston's agents had been working through the holidays, moving through Sheffield's public houses and lodging rooms with the careful precision of men recruiting for a covert operation. The mission was audacious in its simplicity: steal Sheffield's accumulated knowledge by convincing its master craftsmen to abandon centuries of tradition for American wages and Pennsylvania opportunity. Thomas Firth received the proposal on a gray morning that promised nothing but another day of crucible work in his family's traditional shop. Third-generation teamer, the elite craftsman who poured molten steel from white-hot crucibles, Firth possessed knowledge that Sheffield's guilds guarded more carefully than bank vaults. His grandfather had supplied steel for the Duke of Wellington's cavalry sabers. His father had perfected techniques that armed British industry during its expansion across global markets. Now, at 47, Thomas commanded respect that came only from handling 1600-degree crucibles with the steady hands of a surgeon and the intuitive timing of a master musician. The American offer represented more than employment. It was industrial treason of the highest order. Disston's agents promised wages double what Sheffield paid, company housing in Pennsylvania's cleaner air, and partnership in perfecting processes that English workshops treated as unchangeable tradition. More tempting still, they offered escape from guild restrictions that limited innovation to incremental improvements approved by masters whose authority rested on maintaining existing methods rather than advancing them. Firth recruited 11 companions with the methodical care of a military commander, selecting troops for a dangerous mission. Each man brought specialized knowledge essential to crucible steelmaking's complex choreography. Samuel Hartley understood clay preparation, the precise ratios of Stourbridge clay mixed with ground fragments of old crucibles that created vessels capable of surviving thermal shock. William Broadhead read furnace temperatures by flame color with accuracy that mechanical instruments could not match. Robert Ibbotson knew the exact moment when molten steel achieved perfect consistency, recognizing the subtle changes in surface tension and color that indicated complete carbon distribution. The exodus began in February, staggered departures designed to avoid suspicion from Sheffield masters who would view such defection as betrayal of blood bonds stretching back generations. Each craftsman carried knowledge that had never been written down, never been codified, never been shared outside family workshops where sons learned by watching fathers perform techniques refined through decades of dangerous work. They brought intellectual property worth more than gold, the accumulated wisdom of English steelmaking's greatest houses. Their arrival at Tacony transformed Disston's struggling furnaces from expensive experiments into precision instruments. Firth immediately identified fundamental flaws in American crucible construction. The clay composition was wrong, too much pure Stourbridge clay, not enough recycled crucible fragments. The mixture lacked the balanced thermal properties that allowed English crucibles to expand and contract without cracking. More critically, American workers had been treating crucible preparation as mechanical work rather than chemical artistry. Each batch required individual attention, clay mixed to precise consistency based on atmospheric humidity, furnace conditions, and even seasonal variations that affected raw materials. The breakthrough came during the first week of March, when Firth revealed Sheffield's most closely guarded secret, the firing rhythm that separated master craftsmen from mere furnace tenders. True crucible steelmaking required exactly 3 hours and 20 minutes of heating, with crucibles rotated every 45 minutes to ensure even temperature distribution. The timing was critical, too short, and carbon failed to distribute uniformly through the steel. Too long and excessive heat degraded the metal's molecular structure. American workers had been guessing at these intervals, producing inconsistent results that reflected their lack of systematic knowledge. Under English guidance, Disston's furnaces achieved temperature stability that had previously seemed impossible. The Pennsylvania coke that had frustrated earlier attempts now revealed its advantages, burning cleaner and hotter than English coal, reaching 1600 degrees Celsius with less fuel consumption and more consistent heat distribution. Carbon content stabilized at 1 1/10%, the precise balance that created steel hard enough for lasting sharpness, yet tough enough to survive repeated filing and re-sharpening. Production statistics documented the transformation with mathematical precision. Weekly blade output jumped from 200 pieces to 1,200. Crucible failure rates dropped from nearly 50% to under 10%. For the first time since construction began, Disston's American operation matched Sheffield quality, while maintaining significant cost advantages. Pennsylvania coke eliminated shipping expenses that added 30% to English steel prices. Abundant local iron ore reduced raw material costs by another 20%. The economics that had seemed impossible in December now approached inevitability, yet success brought new pressures that tested English resolve and American adaptation. Sheffield's remaining houses, recognizing the threat posed by their former craftsmen, responded with industrial warfare designed to crush American competition before it could establish permanent market position. Prices dropped below production costs, as English manufacturers accepted temporary losses to prevent long-term displacement. Rumors spread through British trade associations questioning the loyalty of craftsmen who had abandoned ancestral workshops for colonial opportunities. The English craftsmen found themselves caught between worlds, no longer welcome in Sheffield's traditional houses, not yet fully accepted by American workers who viewed them with mixture of respect and resentment. Their specialized knowledge commanded high wages and supervisory positions, but cultural barriers remained. English methods required adjustment to American materials and working conditions. Pennsylvania humidity affected clay preparation differently than Yorkshire's climate. American iron ore contained mineral traces that altered melting characteristics. Even successful adaptation demanded constant experimentation that challenged assumptions built over generations. March results proved that knowledge transfer was possible, but sustainability remained uncertain. Thomas Firth and his companions had crossed more than an ocean. They had bridged two industrial cultures separated by centuries of different approaches to steelmaking. Their success in adapting Sheffield methods to American conditions represented the first step toward proving that New World innovation could surpass Old World tradition. But Sheffield's retaliation was just beginning, and the true test of American crucible steel lay not in controlled factory conditions, but in the demanding reality of lumber camps and construction sites where quality failures meant economic disaster. The April morning that changed everything began with Thomas Firth striking a freshly forged saw blade with a small hammer, listening for the clear, bell-like tone that indicated perfect internal structure. The sound rang through Tacconi's main workshop, a precise pitch that meant carbon had distributed evenly throughout the steel, creating molecular alignment that would translate into decades of reliable cutting performance. Henry Disston heard that first perfect sing and recognized it as the sound of American Industrial Revolution finding its voice. Within days, the musical quality control system became Tacconi's most distinctive feature. Every blade emerging from the finishing department faced the hammer test, workers striking the steel and listening for the specific frequency that indicated proper metallurgical composition. Blades that rang false, producing dull thuds or discordant notes, went immediately back to the furnaces regardless of their visual appearance or the hours invested in their creation. The rejection rate initially reached 15% as American workers learned to distinguish between steel that looked perfect and steel that performed perfectly. Disston instituted a quality doctrine that shocked workers accustomed to production quotas that rewarded quantity over precision. Any craftsman who forged substandard steel faced immediate dismissal. No warnings, no second chances, no consideration for family circumstances or years of loyal service. The policy seemed harsh until workers realized it protected everyone's livelihood. A single batch of defective blades could destroy customer relationships that sustained hundreds of jobs. Better to lose one position than risk the entire operation to compromise standards that would hand Sheffield manufacturers the ammunition they needed to reclaim American markets. The innovation that transformed quality from inspection to engineering emerged from American industrial philosophy that English workshops had never considered. Unlike Sheffield's traditional methods that relied on individual craftsman skill, Disston developed America's first rolling mill, specifically designed for saw steel production. The massive iron rollers, each weighing 3 tons and powered by steam engines that consumed 200 pounds of coal per hour, compressed finished steel through precisely calibrated gaps that created controlled tension patterns throughout the metal structure. The rolling process achieved what centuries of English hammer forging could not: systematic stress distribution that made blades self-sharpening rather than self-dulling. Traditional saw steel wore away randomly as cutting action removed material from the edge, eventually requiring complete resharpening to restore functionality. Disston's rolled steel incorporated internal tensions that caused the metal to wear away in controlled layers, each filing action revealing fresh cutting surface that was actually sharper than the previous edge. The physics were counterintuitive, but the results were measurable, blades that improved with use rather than deteriorating. Field testing conducted in Michigan lumber camps provided scientific validation for innovations that seemed impossible by European standards. Lumberjacks working 12-hour shifts through white pine and oak reported that Disston blades maintained cutting efficiency through 285 sharpenings compared to Sheffield steel's average of 60. The secret lay in crucible steel's uniform molecular structure, combined with rolling mill stress patterns that aligned crystal formation in ways that traditional forging could never achieve. Word spread through the interconnected network of American craftsmen with the speed of profitable discovery. Carpenters in North Carolina furniture workshops began requesting Distons by name, specifying American Crucible Steel for projects where blade longevity mattered more than initial cost savings. By July, orders reached 2,000 saws per month, production levels that strained Tacony's capacity and forced systematic expansion of furnace operations. Success attracted Sheffield's most aggressive retaliation. English manufacturers slashed prices 40% below production costs, flooding American markets with high-quality steel priced to eliminate profit margins for any competitor. The strategy was calculated industrial warfare, accept short-term losses to prevent long-term displacement by American innovation. Sheffield houses possessed financial reserves built over centuries of global dominance. They could sustain below-cost pricing longer than any upstart American operation, particularly one still perfecting its processes and building customer relationships. The price war created impossible mathematics for smaller American steelmakers who lacked Disston's production efficiency and English expertise. Competitors throughout Pennsylvania and Ohio found themselves trapped between Sheffield's artificially low prices and their own higher production costs. Several manufacturers abandoned crucible steel entirely, returning to simpler processes that produced inferior blades but remained profitable under economic pressure, designed to crush American innovation. Disston responded by doubling down on quality advantages that transcended price competition. His blades commanded premium prices because they delivered value that cheap steel could not match. A saw that lasted 4 times longer than competitors justified higher initial cost through reduced replacement frequency and superior performance. Furniture makers calculated that Disston steel reduced their annual blade expenses by 60% despite costing more per unit. The mathematics of long-term value overcame short-term price sensitivity. The rolling mill innovation attracted visitors from across American industry who recognized applications beyond saw manufacturing. Railroad companies investigated rolled steel techniques for producing rails with enhanced durability. Agricultural implement manufacturers explored stress pattern applications for plow blades and harvester components. The methods pioneered at Tacony represented systematic approaches to metallurgy that could transform multiple industries simultaneously. By August, Tacony employed 1,200 workers producing steel that consistently outperformed Sheffield's finest at 30% lower delivered cost. The combination of English expertise, American materials, and innovative processing had achieved what seemed impossible 6 months earlier: industrial superiority based on systematic improvement rather than copied tradition. Quality control rejection rates dropped to 3%, while production capacity expanded to handle orders that exceeded earlier projections. Yet success bred new vulnerabilities that threatened everything Disston had built. The Great Chicago Fire's aftermath created unprecedented demand for construction materials, including thousands of saws needed for rebuilding efforts. Orders poured in for 10,000 blades within 6 weeks, production levels that would require pushing furnaces beyond tested capacity and accepting risks that quality-focused operations normally avoided. The opportunity represented either the breakthrough that would establish permanent American dominance in steel markets, or the catastrophic overreach that would destroy everything systematic innovation had achieved. The telegram from Chicago arrived on September 15th with the weight of destiny compressed into commercial language. Urgent stop 10,000 saws. Required 6 weeks. Stop rebuilding cannot wait. Stop premium rates. Guaranteed stop reply immediately. Henry Disston read the message 3 times before the full implications settled into his consciousness, like molten steel finding its level. The Great Fire's devastation had created the largest single order in American tool manufacturing history, but fulfilling it would require pushing his furnaces beyond every safety margin that systematic operation had established. The mathematics were simultaneously thrilling and terrifying. 10,000 saws represented 4 months of normal production compressed into 6 weeks. Every furnace at Tacony would need to operate at maximum capacity 24 hours daily, running 18 crucibles simultaneously in conditions that stressed equipment designed for more measured production schedules. The potential profit exceeded $100,000. enough to establish permanent financial security and demonstrate American Steel's superiority on an unprecedented scale. The potential for catastrophic failure was equally vast. Disston made the decision that would define his legacy with characteristic determination. Tacony would fulfill Chicago's order regardless of the risks involved. Workers received notice that the factory would operate continuously until every blade was finished and shipped. Over time, wages doubled. Additional coal supplies arrived by railroad car. Thomas Firth and his English craftsmen prepared for the most intensive steelmaking campaign of their careers, knowing that failure would validate every Sheffield prediction about American industrial limitations. The first week proceeded with mechanical precision that suggested success was achievable through systematic organization. Furnaces heated to 1600 degrees Celsius with clockwork regularity. Crucibles held their structural integrity under sustained thermal stress. Production reached unprecedented levels as 3 shifts of workers maintained continuous operations. Quality control inspections revealed minimal defects. By September 22nd, nearly 2,000 blades had been completed and prepared for shipment, maintaining the exacting standards that had established Tacony's reputation. The explosion occurred at 11:47 on the evening of September 23rd, when thermal stress finally exceeded the structural limits of crucible steel production, pushed beyond rational boundaries. 7 crucibles shattered simultaneously during the evening shift, spraying molten steel across the furnace floor in ribbons of liquid fire that reached temperatures capable of melting iron. The sound was unlike anything workers had experienced, not the clean crack of single crucible failure, but a cascading destruction that seemed to tear the night air itself. Thomas Firth was positioning an 8th crucible when the catastrophic failure began. Molten steel splashed across his arms and chest as he attempted to control the disaster that was consuming months of careful preparation. The burns were severe, second-degree injuries across 30% of his upper body that would require weeks of recovery and leave permanent scarring. More devastating than physical injury was the loss of his expertise at the moment when Tacony most desperately needed English knowledge to salvage American ambition. 3 furnaces cracked under thermal shock, their brick linings damaged beyond immediate repair. The specialized refractory materials required for reconstruction would take weeks to obtain and install. $15,000 worth of steel, representing 2 months of normal profit, cooled into twisted scrap metal that mocked every calculation about American industrial superiority. The molten rivers that had flowed across Tacony's floor carried with them the dreams of workers whose livelihoods depended on proving that New World methods could surpass Old World achievements. Without Firth's intuitive understanding of crucible behavior and furnace management, quality control collapsed with mathematical inevitability. American workers, despite months of training, lacked the generational knowledge necessary to maintain consistent results under emergency conditions. Carbon content varied wildly as inexperienced hands misjudged timing and temperature. Rush production schedules forced acceptance of substandard steel that would have been rejected under normal circumstances. The musical quality control system that had distinguished Tacony's operation became a source of frustration as blade after blade failed to ring with proper pitch. Within 2 weeks, defective Disston saws began appearing throughout Chicago's reconstruction sites. Blades that should have lasted decades dulled after hours of use. Steel that appeared perfect in factory conditions revealed fatal flaws under the demanding reality of construction work. Carpenters who had trusted American promises found their tools failing at critical moments when building schedules allowed no delays for equipment replacement. The reputation that had taken years to establish crumbled with each returned shipment marked unsatisfactory. Orders began canceling with the swift brutality of economic reality. Construction contractors who had committed to Disston steel switched to Sheffield suppliers whose reliability was proven by centuries of consistent performance. The premium prices that American innovation had commanded disappeared as customers chose traditional quality over experimental promises. By October 15th, Tacony's order book had shrunk from months of backlog to weeks of uncertain commitments. Sheffield manufacturers responded to American failure with strategies designed to eliminate competition permanently. Prices remained artificially low to prevent any recovery that might allow Disston to rebuild his operation and reputation. English trade publications celebrated the vindication of traditional methods over colonial experimentation. Marketing emphasized the dangers of trusting critical applications to manufacturers who lacked the accumulated wisdom that only generational experience could provide. The human cost extended beyond financial losses to touch every family whose security depended on Taconi's success. 1,200 workers faced potential unemployment as production schedules contracted and orders evaporated. The company houses that represented American industrial paternalism at its most benevolent became symbols of vulnerability in an economy where innovation without execution meant disaster for entire communities. Children who attended Disston's company school wondered if their fathers would find work elsewhere, abandoning the dream of American steel supremacy for the practical necessity of steady wages. Henry Disston walked through his damaged furnace hall on October's final evening, surveying equipment that represented both triumph and catastrophe. The rolling mills that had revolutionized steel processing stood idle. The quality control stations where workers had once listened for perfect pitch remained silent. The systematic innovations that had promised American dominance over European tradition lay dormant, awaiting either resurrection or abandonment. The impossible standard he had set for himself and his workers, steel better than Sheffield's finest, seemed more impossible than ever as winter approached, and creditors calculated the mathematics of industrial failure. The breakthrough came not from desperation, but from observation, as Hamilton Disston spent the winter of 1873 studying failure with the methodical precision his Civil War engineering experience had taught him. While Thomas Firth recovered from burns that would leave permanent reminders of September's catastrophe, the younger Disston recognized that their fundamental approach had been flawed from the beginning. They had been copying Sheffield methods instead of perfecting American ones, treating superior Pennsylvania resources as substitutes for English materials rather than advantages that required completely different techniques. The revelation emerged from Pennsylvania's geological gifts that English steelmakers had never encountered. The coke produced from local coal burned 20% cleaner and 30 degrees hotter than English fuel, creating furnace conditions that Sheffield's traditional timing could not accommodate. More significantly, Pennsylvania iron ore contained lower phosphorus levels than British sources, a chemical advantage that reduced processing time while producing purer steel. Hamilton realized they had been handicapping American materials by forcing them through European methods designed for inferior resources. The technical revolution began with modified crucible design that abandoned English dimensions entirely. Hamilton's new crucibles held 40 pounds of steel instead of 34, with walls thick enough to resist thermal shock while accommodating the intense heat that clean-burning Pennsylvania coke produced. The larger capacity meant fewer crucibles per batch, reducing failure points while increasing individual yield. More importantly, thicker walls absorbed and distributed heat more evenly, eliminating the stress concentrations that had caused September's catastrophic failures. The systematic victory that followed proved American innovation could surpass European tradition through scientific method rather than inherited wisdom. By spring 1874, Taconi operated 24 furnaces in perfect coordination, each producing consistent results that matched theoretical calculations rather than depending on craftsman intuition. Quality control improved to 99.2% acceptance rates as systematic processes eliminated the variables that had plagued earlier operations. Production capacity expanded to industrial scales that Sheffield's artisan workshops could never match. 5,000 pounds of crucible steel per day flowed from furnaces that operated with mechanical precision, maintaining 1,600-degree temperatures through steam-powered bellows systems that delivered consistent air pressure regardless of weather conditions or human fatigue. The integration of American mechanical engineering with English steelmaking knowledge created manufacturing capabilities that neither tradition could achieve independently. Field testing conducted by Pennsylvania railroad engineers provided scientific validation that crushed remaining skepticism about American steel quality. Railroad maintenance crews reported that Disston blades maintained cutting efficiency through 400 sharpenings while preserving edge geometry that actually improved with use. The uniform molecular structure created by modified crucible methods produced steel that filed away in controlled layers, each sharpening revealing cutting surface that was more perfectly aligned than factory finishing could achieve. The contrast with modern manufacturing highlighted the fundamental difference between durable goods and disposable products. Contemporary carbide-tipped saw blades used tungsten carbide tips brazed onto soft steel bodies that became useless once the hardened cutting edge wore away. These blades typically lasted 8 to 10 hours of continuous use before requiring complete replacement, costing $25 per blade for single-day performance. A Disston blade cost $3 in 1876 currency, but lasted decades through hundreds of sharpenings that maintained original cutting efficiency. Philadelphia's Centennial Exhibition of 1876 provided the stage where American industrial achievement displayed itself to global audiences. Disston's exhibit featured working demonstrations of crucible steel production, rolling mill operations, and quality control systems that had transformed traditional steelmaking into modern manufacturing. International visitors witnessed production rates that seemed impossible by European standards, consistent quality at industrial scale through systematic processes rather than individual craftsmanship. The economic transformation extended beyond steel production to reshape entire industries that depended on cutting tools. Furniture manufacturers calculated that Disston blades reduced annual tool expenses by 60%, despite higher initial costs. Lumber operations reported productivity increases of 40% as workers spent less time sharpening tools and more time cutting wood. The mathematics of long-term value overcame price sensitivity as customers recognized superior performance justified premium pricing. By 1876, Tacony employed 8,000 workers producing 200,000 saws annually across 300 acres of integrated manufacturing facilities. The company town that had once seemed like overconfident speculation became a model of American industrial paternalism, providing housing, education, and health care for families whose livelihoods depended on maintaining quality standards that exceeded anything European competitors could match. The global impact reached beyond individual success to demonstrate American manufacturing philosophy that would reshape industrial competition throughout the late 19th century. European workshops that depended on guild traditions and inherited knowledge found themselves competing against systematic innovation that could adapt ancient processes to modern materials and industrial-scale production. The lesson resonated across multiple industries as American manufacturers recognized that superior raw materials required superior methods to achieve their full potential. Sheffield's response evolved from dismissive confidence to grudging recognition that American competition represented permanent change rather than temporary disruption. English manufacturers began adopting modified crucible techniques and expanded production capacity to match American efficiency. The global steel industry transformed as systematic innovation replaced traditional methods that had remained unchanged for centuries. Henry Disston's achievement proved that American ingenuity could take processes perfected over generations and improve them through scientific method, superior materials, and relentless commitment to quality that served customers rather than preserving traditions. His steel cut through more than wood. It cut through assumptions about European manufacturing superiority and established American industry as a force capable of surpassing any competitor through systematic innovation applied to abundant natural resources. The legacy extended far beyond individual success to establish principles that would guide American manufacturing throughout its rise to global dominance. Quality achieved through systematic processes rather than individual skill. Innovation focused on serving customer needs rather than preserving traditional methods. Scale achieved through mechanical precision rather than expanded craftsmanship. These concepts, proven in Tacony's crucible furnaces, became foundations for industrial achievements that would define American economic power for the next century.